first of all, you're going to have to figure out where the two graphs intersect. Yeah, right. On page 9. So we need to find out where these two graphs intersect. And we do that just by making the equations equal to each other, because you can use substitution and solve, and you get your 2 points. And technically this part here, you don't even need the y values. You are just interested in what x value to what x value. Then what's really cool about the area between the curves, so if I want to find this area, I feel like green crayon today. There we go. If I want to find this area right there, it doesn't matter that part of it's above the x-axis and part of it is below. When you go from -2 to 2, of one of them subtract the other one. Now, does it make sense we always do the top one, subtract the curve below? But if you screw up, all that you're going to get is a negative answer, and instead of rewriting the whole question, you could just go back and like, oh, I meant to put absolute values around the whole thing all the way through. But what's nice about this is you could integrate each separately, but you can simplify. And by simplifying, it usually makes your integral easier to do. And then you plug in the one, plug in the other. I know you know how to do that, so I'm not showing all the work there. But relatively easily, we can get crazy areas very quickly. I'm going to skip the next question. I'll put the answer on the video. When I post the notes on Teams, you can access it from there as well. But just so that it's not very hard, but just to save us some time. Okay? Everybody done with this one? So, here's the question. They give you a coast graph. They give you the line y equals x. They just wonder about the first part in quadrant 1 and the y-axis, so that's the shaded part, that's the area I want to find. Okay? How can I do that? Well, it's the area between the curves from here to the intersection point, and that intersection point I would have to get with a calculator. Once I've got that intersection point, I'd plug that in. Probably I would even store that answer as like a variable in my calculator, like a, and then make my integral go from 0 to a, and from here, it's just a matter of evaluating things and getting the answer. This one's kind of interesting because they want to find the area of the region bounded by the curves, and you got an x cubed graph and a parabola. And if I color code this, there's actually 2 places. We've got this area here that's in between the 2 curves. And we also have this area here in between the 2 curves. And the difference is at one place, the red graph is above the blue graph, and the other place, the blue graph is above the red graph. So if you just went from -2 up to 1, because this is where they intersect at 1, they intersect at -2, and they intersect at 0. If you just did from -2 to 1, well, part of that area would have been positive and part of it would have been negative, and you would get the wrong answer. So we find our intersection points of 0, -2, and 1. And again, you don't need the y values, so it's good enough just to have those x coordinates. But now we have to consider the two regions, the orange region and the purple region, separately. And once you realize this, this is exactly the same as the questions we did before. So you just need to find, right, region 1, the area is going to go from -2 to 0. Region 2, it's going to go from 0 to 1. But in region 1, the red graph is on the top and the blue graph is on the bottom. In region 2, the blue graph is on the top and the red graph is on the bottom. So notice how the subtraction is a little bit different because it's either A minus B or B minus A. Not crazy hard, right? And then, again, life's going to be easier if we can simplify. So in both of these, we simplify, and you'll notice that they're exactly the same equations, but one of them has positive values and the other one has negative values, and vice versa, where and then we integrate. I feel like saving time and just telling you from there you could just add the two answers together. Again, the mental math and writing it down, you're not going to check that later. I know that you can do it. So if we can save ourselves a little bit of time, quicker we can start studying for the exam. Super excited about that. If you had a calculator, you could do all of this and more very quickly. Right? It's way faster, but as I say, it says here, not as much fun. But you could put one of your functions in y1, one of your functions in y2. And once you have them in there, you could even do the integral button and go y1 minus y2 without having to rewrite everything, which is really helpful for using your calculator that way. So while you're doing your exam prep, sometimes you're going to come ask me questions. I'm going to say, hey, the way that you did it's great, but I can show you some shortcuts to use on your calculator as well. This is a super cool question. You've got your cos graph and your sine graph. And you want to find that area in between them. So when is sine x equal to cos x? You know that that's at pi over 4 from your unit circle. And then to find that area, it would be the integral from 0 to pi over 4 of cos x minus sine x. Which we could integrate each of them separately. Integral of cos is positive sine. Integral of negative sine is positive cos. And plug in your values from your pi plate, and you get the square root of 2 minus 1